When batch processing fails for just a few items in a large list, how do you give users clear feedback without stopping everything? You'll see how to build a resilient, FastMCP tool that processes items one by one, logs detailed errors for failures, and still returns a complete success failure summary. The pattern keeps execution running while giving clients structured error data for each problem.
At MCP tool, Async def batch process items, list str ctx, context, dict. Process multiple items, logging errors for failed items. Successful equals 0. Failed equals 0. For item in items, try. Hash process item. Successful plus equals 1. Accept exception as E. Await CTX error. F failed to process item str E. Extra equals failed item. Failed plus equals 1. Return successful failed.
This demonstrates the partial success pattern for batch operations, where individual failures don't halt the entire process. The technique combines error isolation with structured logging, allowing systems to continue processing valid items while capturing detailed failure information. What makes this distinctive is its ability to maintain progress while preserving complete error context for each failed item. The pattern works by treating each batch item as an independent unit of work, wrapped in try-catch blocks. Failed items trigger contextual error logging through the framework's client communication channel, while successful items proceed normally. This separation of concerns keeps processing logic clean while ensuring all execution outcomes are properly recorded and communicated. This approach is critical for resilient data pipelines and user-facing batch operations. It prevents single-item failures from derailing entire jobs, provides immediate feedback through client logging, and maintains audit trails for troubleshooting. The trade-off is slightly increased complexity in tracking partial results, but the benefit is robust error handling without sacrificing throughput. Let's break it down line by line.
At MCP tool, Async def batch process items, list str ctx, context, dict. Process multiple items, logging errors for failed items.
This defines an AI callable tool using the @MCP tool decorator. The function processes batches of string items while accepting a context parameter for logging and progress reporting, a standard pattern in FastMCP tools. The async signature enables non-blocking execution during batch operations.
Successful equals 0.
Initializes a success counter to track processed items. This metric will be returned in the final result dictionary, providing visibility into batch operation outcomes.
Failed equals 0.
Initializes a counter for failed items. This tracks processing errors separately from successes, enabling precise error reporting in the final result dictionary.
For item in items,
this iterates through each item in the input list. The loop processes items sequentially, enabling individual error handling and progress tracking for each element.
Try.
This starts an exception handling block, isolating each item's processing. It ensures one failure doesn't interrupt the entire batch, maintaining progress through the list. This is the defensive programming pattern for resilient batch operations.
Hash process item. Successful plus equals 1.
This placeholder marks where the actual item processing would occur. The successful counter increments immediately after processing, assuming success unless an exception occurs, implementing the optimistic concurrency pattern.
Accept exception as E.
This catches all exceptions during item processing, preventing crashes from single failures. The broad exception handler ensures no error slips through, while as-e captures the error details for logging. This is defensive programming. The batch continues processing remaining items even if some fail.
Await CTX error.
This invokes the context's error handler, designed for structured error reporting in FastMCP tools. It logs the failure with metadata while allowing batch processing to continue, preventing one bad item from halting the entire operation. The await is required because error handling is asynchronous in FastMCP's context system.
F failed to process item SDR-E.
This F string formats a detailed error message that includes both the failed item and the exception text. The structured message ensures logs contain actionable debugging information, while the SDR-E call safely converts any exception type to a readable string.
Extra equals failed item.
This attaches contextual metadata to the error log. The extra dictionary adds structured data to the log entry, enabling precise filtering and analysis of failed items in monitoring systems. All FastMCP tools should include relevant context in error logs for observability. This closes the CTX error call, finalizing the error log entry with the formatted message and extra metadata. The trailing parenthesis ensures the error is properly recorded before continuing execution, maintaining the error handling flow.
Failed plus equals 1.
Increments the failure counter each time an exception occurs. This maintains accurate statistics for the batch operation, allowing the function to report how many items failed processing. The pattern ensures the return value reflects the complete operation status, not just successful cases.
Return successful, failed.
This returns a structured result dictionary with success failure counts, providing observable metrics for the batch operation. The explicit return type ensures consistent output for both AI and programmatic consumers, matching the tool's declared schema. Resilient batch processing pattern. This at MCP tool implementation demonstrates FastMCP's approach to partial failure handling, where individual item failures don't abort the entire batch operation. The error context's extra parameter becomes invisible to the tool's return value, yet remains fully queryable by the client. Partial success is the only kind of success at scale.
The batch that fails completely succeeds completely.